All right, hello everyone and welcome. It's been a couple, 3 weeks since I've seen you because of spring break and I was out of town for a conference, so hope everybody's doing well. There was an exam last week that I was out of town for, but from what I hear from my TAs, everything went about as well as it could have, and I'm sure you're all interested in when you'll be getting your grades back. They are not done yet, otherwise you would have already had them, but we're almost done with the grading. I just have one final step, which is to go track down all of the exams that didn't scan properly and figure out, regrade the last few exams that have some problems. So I'm hoping to get that done tomorrow. You should have your exam grade tomorrow. The process will be the same as it was for the last exam. You'll have about a week to submit exam regrades, and that'll all go through GradeScope. So yeah, in terms of the rest of the semester, it's kind of a good time to check in and kind of see where we're at in terms of the calendar. So I just wanted to remind you that we're kind of in the home stretch here as far as this class is concerned. We've got 2 exams down. For many of you, there's just 1 exam remaining, although if you had to use your drop for whatever reason, then there is another additional final exam that you can take to account for that. We've got three units left, so we're going to start Unit 7 today. We've got 8 and 9 coming up over the next couple weeks, and then 1 more exam for most of you, and that'll be it. That'll wrap us up for this semester, for this class. So we're just going to kind of finish up. Now is another good time for me to remind you all. I know this is a busy time of year for a lot of us, me as well. It could be stressful. I know this isn't the only class you're taking. You've got lots of other classes with other assignments and projects and exams and things like that. Please come talk to me if you're struggling in this class, if you're having trouble keeping deadlines. I don't want that to be a reason for you not to do well in this course, especially if you've been doing well up until this point. Just because you're out of late coupons, well, let's talk about that. In fact, if you're out of late coupons, shoot me an email. Maybe it's not unusual for me to give you a few if that's what you need to bridge the gap. I don't like to let deadlines be the reason that people do poorly in the class. I just don't think that's a good reason. So if you're struggling getting stuff in on time, please talk to me. I can and will be flexible with those things within reason. Just want to make sure you're all aware of that. Okay. I think that is all of my announcements and reminders for today. So I'm going to go ahead and hop into today's topic. It's actually a very, very, very important one. In fact, we've been basically working the entire semester up until this point. So everything that we've been working on up until this point has basically been gearing you up for what we're going to be talking about today, which is writing classes, using classes, and creating and using objects in our code. We've actually already done a little bit of this. It's sort of hard to avoid doing this in our programs. We just have sort of obscured it, not made you worry about it too much. The classic example of an object that you've already seen and used plenty of times is scanner. Scanner is a great example of an object that is provided to us by Java that we are welcome to use for whatever purposes we want. But we want to be able to create our own classes, our own objects. So today is all about that. And Java is a great language to do this with because Java's sort of whole reason for existing is to really embrace and lean into this idea of object-oriented programming. So what I'm about to introduce you to today is a specific style of programming called object-oriented programming, which so happens to be the most common programming style that we deal with today for the most part. So yeah, we're going to start by taking a look at classes and talking about what they contain, what they can do for us. We'll take a look at some code examples today. There's really there's going to be some new topics today, but a lot of what we talk about today is going to be stuff from the past. We're just going to be looking at it in a little bit of a different way, in a little different context. using objects and classes. So yeah, let's go ahead and hop right in. I'm going to switch over to the exercise repository. I want to remind you all, this is the third sort of part of the course. So we've finished going through the exercises batch 2. We're now on to exercise batch number 3. So if you need to grab the batch of exercises that I'm going to be working on today and for the rest of the semester, the link to do that is on the Module 7 page. So if you go to the course on Canvas and go down to Module 7 exercises, you'll find the link to grab the repository. So go ahead and do that if you need to. I've already loaded it up into Eclipse ahead of class, so I'm ready to dive right in. And let's take a look at a class. This is a class, actually, to be fair, everything that you've done up until now has been done in a class. In fact, it's not possible to write a program in Java without using a class. You see this up at the top of every file, right? We haven't really explained what this is or why we do this or what it's for, but now's the time. Now's the time to chat about it. When I'm creating a class, effectively what I'm doing is creating a brand new type to work with. So the types that we've seen are, like integers, strings, booleans, doubles, and then we introduce you to arrays, right? Arrays are also a type that we can use. And those are great. Those are useful for many things, but it's not enough. Sometimes I need to build something that represents a more complex object. And so what classes allow us to do, we're essentially creating a new type. So anywhere that I've used a type in my code in the past, I can also now use this as a type. That's sort of interesting, right? So if I want to create a person variable, I can create a person variable. If I want to create a method that accepts a person as a parameter, then I can do that, right? I can use person anywhere that I would normally use a type. That's ultimately what we're doing when we are creating classes. We're saying that, okay, the existing types to us aren't good enough for what we need. I'm going to create a brand new type. And then once we've made that decision that we're going to create a new class, a new type, we have to decide what goes in that class. And so there's two primary categories of things that I expect to find in the class. The first one is right here. In fact, it's almost always going to be at the top of the file. You can put these wherever you want, but convention, right? For the sake of consistency and ease of reading, we typically keep these up at the top. These are what we call instance variables, or you may hear me refer to them as fields or properties or attributes. I mean, all of those terms I kind of use somewhat interchangeably to refer to the same thing. And these are, I mean, the word property is kind of a good one, or attribute is kind of a good one, right? These are the things that are describing the class. So instance variables are the pieces of data that we use to describe a class. And so the way to think about this in practice, I'm making a class to represent a person, right? So every single person that I create is going to have a name. Every single person that I create is going to have an email address, and every single person that I create is going to have a phone number. That's what we've decided for this class. There are other things that I could maybe choose to represent here as well. Person has an age. Person has a hair color, right? All kinds of things that would be acceptable attributes, but for whatever it is that we're trying to do in this program, this is the set that we've landed upon. And so I think the most important thing to keep in mind is that there's a relationship between these instance variables and the class that we're in. I actually will often say this out loud. Instance variables are the has-as. And what I mean by that, I'd say that a person has a name, right? Person has an email address. Person has a phone number, right? If I'm able to say that phrase out loud and it makes sense, then that's a good indication that this is a good instance variable to include in your class. If you say something out loud and it doesn't make sense, right? Person has an interest rate. Well, what? That's not something I usually associate with a person. That's something I associate with a bank account or something like that, right? So saying it out loud kind of raises those alarm bells like, that's not a good fit. It's not a good fit for this class. So using that has a relationship is a good way to tell if your instance variables are in the right place or not. The formula for creating your instance variables is actually pretty straightforward and pretty easy. You'll notice these are not inside of a method, right? So before now we've had the main method, and then in recent weeks I've introduced ways that we can include other methods, right? And we're still going to use those. You can see those down below. We're not done talking about that. But these don't exist within a method. We say another name for instance variables, these are class level variables. And what that means is that this variable name, you'll see it's highlighted in blue, it can be accessed within any method inside of this class. So this instance variable is able to be accessed anywhere that we want to within this class. That's the advantage of declaring these instance variables outside of the class like this. They're all going to start with this. This is called an access modifier. You've actually already seen this. You've seen the opposite of this one, which is public. We've been doing basically everything as public before today. But starting today, we're going to start marking things as private. Actually, I think it's very, 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 very important to mark all of your instance variables private. And I'll give you a little example a bit later on in class to illustrate why I believe that to be the case. But otherwise, these are just like other variables. So you can see that after marking them private, I just say, all right, this has a type, and this is the name of the variable that I wish to have this instance variable be called. So when I'm creating a class, one of the first things that I'm going to do is try to identify what the instance variables of that class should be. What are the hasas? What are the hasas of that class? So if I'm making a class to represent a cat, for example, some of these might be the same. My cat has a name, right? So I might expect to see a cat class to have an instance variable called name, but I probably wouldn't expect to see these two in a cat class, right? It would be a little silly. Instead, I might see something like fur color or, age, number of lives, right? Stuff like that. So make sure that your instance variables are related to the class that you're in. That is extremely, extremely important. So that's one part of what I expect to see in a class file, are the instance variables. The second category of things that I expect to see in the file is everything else, which are methods. So the two categories of things I am going to find in a class are instance variables and methods. And when I say methods, I mean, the same exact methods that we've been talking about for the last few weeks now. That's what we're discussing, except you'll notice that unlike the methods we've been using before, there's a word missing here, right? So that static word is now gone from a lot of these, with one exception being our main method down here. I actually think that's a good thing to be aware of. I would even take that a step farther and say that from here on out, starting today, right, Lab 7 onwards, we're not writing static methods anymore. We're done writing static methods for the most part, with main being the exception. Main has to be static. That is required. That is a requirement of Java. But other than our main method, you'll notice that none of these are marked as static, and there's a reason for that. Static methods operate without objects. They operate on their own. You can think of the method as just kind of existing by itself in the world. And that's useful for some things, but it's a kind of an older way of thinking about our programs. It's kind of an old school way of thinking about coding. Non-static methods, like we see here, or instead of calling them non-static, I guess the more correct way would be to call them instance methods. Just like we have instance variables, we have instance methods. These are non-static methods. These are going to operate upon instances of an object. So static methods do not require objects. They do not require the use of objects to run, but non-static methods do. And we're very much interested in using objects. That is basically all we're going to be doing from here on out for the rest of the semester, is using objects. So our days of writing static methods are basically over in this class, with maybe a few exceptions. But let's talk about this in a little bit more detail, because not all methods are created equal. In fact, up here we have a special method that we're going to spend a lot of time talking about today, called a constructor. So a constructor is a method. It's a special kind of method that serves one purpose. Its purpose is to create an instance of the class. That is the constructor's role in life, which you might still leave you a little bit confused, right? I used some computer science-y jargon to describe that, but let me try and explain it in more plain English. This class, this person class, is a template. This is you can think of it like a cookie cutter almost, right? So all people that I create are going to follow this template, but just having the template on its own does not give me any actual people. I need to create instances of this class in order to have actual people with actual data in them. It's kind of similar to how when I was defining a method, right? Just having that method code doesn't actually do anything. I have to call the method in order to actually make it work properly. So the same thing is true for our objects, for our instances. So the constructor's role in life is to create an instance. It literally births an object into existence. Before there was nothing, now there is a person object. Now I have a person object, an instance of the person class. And this constructor can be used many times, many times. So if I wanted to create a representation of every single person who's in this room right now, I would call this constructor once for every single person who's in this room right now, right? And when I call the constructor, I'm going to supply these parameters such as name, email, and phone number, and those values are going to get stored into the instance variables. So the constructor's role is to create an instance of a class, of an object. The way that it accomplishes that is by setting all of the instance variables. So if I have 3 instance variables up here, I expect to see 3 variable assignment statements in my constructor. If I have, 8 instance variables up here, I expect to see, at a minimum, 8 variable assignment statements here to tell me what the values of these instance variables should be when this person gets created. I don't want to leave any of these blank. That is a bad thing. That is a situation that we wish to avoid. So you can see that the way the constructor does that is by accepting these values in its parameters. There are other ways that we can accomplish this goal as well, but this is very common. And so what does it mean to actually create an instance? Let's scroll down a little bit and take a look. Here I'm creating a variable. Here I'm using person as a type. It's a very important concept from today, right? I have a class. It's called the person class. And now that I have that class, I can say I want to create a variable of type person. And when calling the constructor, we see this word new. That is a great clue to you that a new instance of an object is about to be created. In this case, we're creating this person right here with this email address and this phone number. If we look a few lines lower, we'll see that we call the constructor a second time. This time we pass in a different name and a different email and a different phone number. So by the time this code is finished, I expect to have 2 instances of the person class, each with its own separate values. If I look inside of P1, I see this person's information. If I look inside of P2, I'm going to see this person's information. And honestly, P2 doesn't even know that P1 exists. right? They're completely independent, completely separate from another, operating on their own. Question?
Is person essentially just a index with variables then?
So if you look behind the scenes, actually, yes. A lot of what it's doing is just keeping track of each of the unique instance variables that exist for each instance. There is a bit more to it than that, because this code has to go somewhere too, but that's outside the scope of this class. Yeah, it's a great question. Love to chat with you about it in office hours sometime. Yeah.
Can you initialize the constructor into the instance variables in the top, like you just said, like private string name equals?
Sure. So you can do this. This is what you're asking. Am I correct? Yeah. You can do this. I actually prefer not to do it this way. Although I wouldn't necessarily count it wrong if you did it on an exam or something. It's just not my preferred style. The reason being that I now have to look in a few different places to figure out how these variables are getting set. Doing it all in the constructor means that I just look here and I see how they're all getting set. Whereas if I spread it out across different places, that can get kind of confusing. This also will have the effect of making everybody's name Doug, which is probably not what I want. Well, me personally, I guess, would be confusing, but yeah, anyway. So yes, you can do this. This is actually something called a default value. I'm going to show you another way to do that in just a second. Great question. Was there another question?
How is creating an instance different from a method call?
How is creating an instance different from a method call? Great question. So that kind of goes to back to what methods are doing for us. Methods are behaviors. Methods are actions being performed. An instance is a thing. An instance is a noun. It's an object. So when I call a method, I'm saying perform this action. When I'm creating an instance, I'm saying make this thing. So that's the big difference. But we can take that a step farther. The way that these methods are written, since they are non-static, remember the difference between how we did things before and how we're doing things now. These methods require an object to run. I cannot call this print method unless I have first created an instance of the person class. At least one, if not more. And then in order to use this method, I don't just say print, I actually have to call it upon an instance. And I can show you what I mean by that. Take a look at this line right here, or actually even this line right here. Both good lines to take a look at. Here's my print method, but it's being called up. So, which person am I printing? If I just say print by itself, that's not enough information. Which person am I printing? I want you to print P1. Or this line is saying, I want you to print P2. So we're attaching the behavior to a specific instance using the dot. When we call methods in an object-oriented way, it's going to go instance dot method. Yeah?
So we can use a non-static method only when the corresponding instance is created.
Correct. You have to have an instance created, which means you have to call the constructor in order to utilize a non-static method. It sounds like more work, but part of what I'm trying to do today is convince you that it's worth it, because objects, A, help us keep our things organized, and B, allow us to perform more complex tasks than we would be able to without them. Yeah, great questions. I know this is also kind of new and abstract and confusing, so please keep the questions coming. I'm happy to, review anything that needs to be reviewed a couple of times if that's what it takes. That's what it takes. In fact, what I would maybe like to do next is show you, take a stroll through the debugger here, because I think it's kind of important to understand how all of this works before we move on and talk about actually writing some code. So what I'm going to do is I'm going to set a breakpoint right here on line 30. That's the line where we first call the constructor to create an instance. Before that happens, if you take a look at my variables window, you'll see that I got nothing. Right? There's no people that exist, no person objects. That is not a thing that has happened. But all right, I'm going to call the constructor, And you'll see that when I jump in here, right, if I click step into, I hop into the constructor and it sets all these values. Hooray, there we go. Oops, I meant to take that out and I forgot. Oh well, I guess we'll find out what happens here in just a second. All right, so I've stepped all the way through the constructor, and once that's done, I get back this instance of the person class. And you can actually look in here and see, here are the instance variables and how they got set, right? The next thing that it says to do is to print P1. All right, if I step into this method, you'll see here I am in the print method. It says print out the name, the email address, and the phone number. But which ones, right? If I have multiple people objects, how does it know which name, email address, and phone number I want to be printed out? Well, again, since I said p1.print, the values that it's going to use for name, email, and phone number are the values that are stored in P1. And if you step through the code and take a look at the output, that's exactly what you'll see. And then if I create a second instance, here's P2, and I call the print method upon that instance, you'll notice that I go to the same place. I'm running the exact same method, the exact same code, right, that I did before. But the difference now is that since I called this on P2, that it's going to use P2's name and P2's email address and P2's phone number here for the instance variables instead of P1. And if I proceed through the code, you'll see that's exactly what we get. So that's actually, again, part of my job today is to convince you that object-oriented programming is useful. I think I've hopefully just illustrated that by showing you that I can reuse this same chunk of code across many different instances of objects. I just have to be careful about which object I'm using that method on. Okay? Any other questions I can address before I move on? Spend a lot. We're going to talk about spend some more time talking about constructors, since that is such an important method and such an important part of understanding how these objects work. So I'm going to move to this car class and write some constructors with you. The instance variables have been declared for us already. So I've got two of them, the model and the year of the car, right? We actually have two constructors here, two of them. That might seem a little bit confusing, but think about what that means. Think about the implications. It's just saying there's more than one way to create a car. Do you agree with that statement? Do you not agree? I don't know that it really matters, because it is absolutely doable, absolutely possible to have more than one constructor in a class. What you see here is pretty typical. If you see a constructor that doesn't have any parameters, this is what's called the default constructor. This is going to create a default instance of the object, meaning that I'll just, so the role of the constructor is still the same. It has to make sure that the model and the year are set to be values, but I'm just going to set them to default values, right? What did it say to use? 2019? So if I don't tell you what the model and the year of the car are that I want to be created, then it's just going to create a generic car with a blank model and the year of 2019, right? That's what this default constructor is doing. That might be useful for me in some situations. There might be other situations in which, no, I want to create a specific car, right? I want to tell you what kind of car to make. And so that's what this constructor is for. You can see here, this constructor has parameters. The goal is still the same. Make sure every single instance variable has a value. So if I come down here, I'm going to set each instance variable to the corresponding parameter. Again, what's the difference between these two constructors? If I call the default constructor, I'm going to get this default vehicle back that has a blank model in the year of 2019. If I wish to have more control over what car is created, then I'm going to use this non-default constructor which allows me to pass in values for the model and the year. And that's what's going to get used for the instance variables. Yes?
Let's say you're trying to make like a lost cargo run and you want to incorporate like the other one whose name is person. Can you like chain together objects like that? Or is there not a good way to do it?
Chain together objects like that.
Like let's say I wanted to attach my like name, phone number, and email in case you like found my
Sure.
contract somewhere. Can I take that other object I just created and like maybe one of my instances?
Great question. So, the question is, can I, combine these classes together if I wanted to associate name, email address, and phone number with the car? Is that possible? Yes, absolutely it is. However, I would encourage you not to do it like this, right? I don't think that's what you're asking me, but just in case, this is not the right way. And in order to understand why, you can use the has a test. Car has a name. Well, some people do name their cars, but that's not really what we're after here, right? I think the other ones make it even more clear that a car is not going to have an email address. Car has an email. That doesn't make any sense, right? So, but think about it. We already have those instance variables. We already have an object to represent a person. And one of the big points for today is that when I create a class, I can use that anywhere that I would normally use type. So if I want to create an instance variable to represent a person, I can create an instance variable using the person class and call it owner, right? And now this is going to represent the person that owns the car. And if I access this instance variable, I can ask it for its name and email address and all that fun stuff, right? So that, I think, is a great illustration of why we like to do stuff like this. And I'm also really glad you asked that question, because this is something you're going to have to do on the next assignment. So it is a skill that is going to come up sooner rather than later. Yep. In fact, while I'm on the topic, even though we're on a little bit of a tangent, consider that so my wife and I are going to buy a new car, which means there's more than one owner. Well, okay, could I have an array of people? The owners, plural? Yes, absolutely. Absolutely. I can have an array of person objects. And this is probably just mad because it wants me to import. Yeah, it wants me to import. I can have an array of person objects. Yes, absolutely. That is entirely possible. So, in fact, this is encouraged. This is a great use of object-oriented programming. Yeah, great question. Back to the constructor conversation that we're having, right? So there can be more than one way to create an instance of an object. In fact, there often will be more than one way to create an instance of an object. But regardless, of how many constructors you have, the role of all of them is the same. Make sure every instance variable has a value by the time that constructor is finished. That is the constructor's job. So the instance variables are either going to get set one of two ways. Either I'm passing in a parameter that I'm expecting to be used to set one of the instance variables, or I'm just going to hard code it in and say this instance variable is always going to be this when I create a new car. And just to make things perhaps even a little bit more confusing, I can mix and match. If I wanted to create a constructor, right, a third constructor, I could. Maybe this one only takes in the model but not the year. So I set, you can tell me what the model is, but the year is always going to be 2019, right? I can mix and match. This seems a little bit silly. I'm not sure why I would want to do things this way, but I have the ability to do that, and there are situations in which that might actually be a reasonable thing to do. We might even see one of those situations a little bit later on today. The other point that I want to make clear before we move on to some other stuff, these are methods. Constructors are methods. They look a little different. They're special methods. They serve a very specific purpose, which is to create an instance of an object. But they are methods. Just like any other methods, you can tell by the parentheses they have here, the fact that I'm passing in parameters. There is one thing that's missing. So normally I would see, well, we're not doing static today, so that's gone. But normally I would see a return type here, right? Like void or int, something like that. But for the constructors, I actually don't see that return type here. I would argue that there is a return type, but we don't type it because it's mostly implied. This method is creating a car, right? The return type would be car, so they decided that it's a little silly to say public car. I kind of agree, right? It's implied. I am creating an instance of this class. That is what's being created and returned here. So what does that mean for you? If you see a method that doesn't have a return type, that's probably a constructor. Although it also has to have the same name as the class, right? That's also required. Same name as the class, no return type, that's the constructor. Also notice the order that things appear in the file. Instance variables first, then constructors, plural if I need more than one, then other methods. So any other methods that aren't the constructor come at the end. Will your code still work if you put things in a different order? Yes, but myself or the TAs will be a little confused, right? Because they're not going to see the stuff where they expect to see it. Okay, but again, let's remember that just having this class doesn't actually do anything. It's just a template, right? It's quite literally a cookie cutter, right? When I call the constructor, I make a new cookie, and that cookie has, whatever values for the instance variables that I want it to have, and then I call the constructor again, and I stamp out another cookie with whatever instance variables I want that one to have, right? So this is a template. This is a blank form waiting to be filled out, right, with values. So in order to do that, we have to call the constructor. We have to call the constructor. Constructor is a method, so calling the constructor is similar to calling a method, with the exception that we use this new keyword. So whenever you see that keyword new in purple, I want your brain to think, I'm creating a new instance of an object. That is quite literally what that means. I am calling a constructor. That's quite literally what that means. My brain has been thoroughly trained. Anytime I see new, I say, oh, here comes a new instance. Here comes the constructor. That's what's about to happen. So we'll use both constructors here. I'll say, I'll just use the default constructor for the first one. No parameters, right? No parameters. So after this, I expect to get this car, this default whatever car. And then for the second car, I'll use my other constructor. And let's see, which one does it want first? It wants the model first and then the year. Okay, so I drive a Honda Fit. It's a 2012. I'm about to sell it though, so if anybody's looking for a Honda Fit, 100,000 miles, it is a stick. People can't drive stick anymore, but yeah. So when I call print on car 1, I expect to see the default information pop out. When I call print on car 2, I expect to see this information pop out, right? Very similar to the debug process that I walked you through before. There we go. Here's the default values that came from the first print, and here are the values that I supplied for the second print. And again, I'm not limited to 2. I can create as many cars as I want. I can call the constructor as many times as I want, create as many instances as I want. Any questions? Yes?
What happens if we try to input values for the default?
Try to input values for the default constructor. Okay, so yeah, the question is, what if I try to put some stuff here, like this? So, if I put the exact same thing in, that means I'm not using the default constructor anymore. Because what it does when I call this method, it says, all right, they called this method with a string and an int. Do I see any versions of the constructor that accept a string and an int? I do. It's not the default constructor, it's this one.
So because the values are already set for the default constructor, once we don't have to input any values, and the computer will know that we're calling
Well, I think the question you're really asking is, how do I know which version of the constructor I'm using? It's based on the parameters. If I don't put any parameters in, it's going to do this one. If I do put parameters in, specifically a string followed by an int, it's going to do this one. Any other combination of parameters, and it's going to say, I don't know what you're talking about. That's not a thing I know how to do. So these are my two ways of calling the constructor, and I get to pick. Do I put parameters in here or not? And that's what specifies which one it gets used. Good question. Yes?
And it's during the third step where you're calling the constructor, that's where you're saying, like, that's where you specify the number of cars, like the number of cars, and then you're defining.
I'm not specifying the number of cars anywhere. The number of cars that I have is purely based on the number of times I call the constructor. So in this case, I have 2 cars just because that's all I've created, right? When the program starts, I have 0 cars. After I call this constructor, it creates 1 for me. This constructor is going to create another car for me, and if I want to, I can make more, right? I just have to call the constructor to make as many cars as I want. So if I'm running a Honda dealership, I can have a car created for every car on the lot if I want to, but I have to make them. I have to call the constructor that many times. Yep. Yeah, good questions. I know this is new and abstract, so keep those questions coming. It definitely takes a couple trips through this info before it really starts to sink in for most people. So don't feel like you should be getting all of this to click right away. It's definitely needs some time to sink in, I think, in my experience. Okay. So we've got our instance variables. Those are our properties. That's describes the values that our class contains. We've got our methods. These are the behaviors. This describes what our class can do. What are the things available for our class to do? And so, you'll notice that so far these classes have been rather minimal, rather bare bones. But if I was actually making a car class, I'd probably come down here and have a drive method, right? Because cars can do that. Cars can drive. Maybe I'd have, fill tank, right? Because that's something I can do to a car. I can fill the gas tank. And for each of these methods, I'd have to ask myself, what instance variables would be affected by driving a car? What instance variables would be affected by filling the tank? Well, right now, I don't have any indication of a gas tank. Maybe I need to add one. Maybe I need to add an instance variable to represent how much gas is in the tank, right? That is a thing that can be done. And as a programmer, that's what I'll do, right? I don't have a professor telling me what things to put in my classes. I just add them in as I've determined that I need them. Let's talk about another special kind of method that's also very commonly used. It's called an accessor. So I'm going to return to, I'll just use this student class, which is very similar to the person class. You'll notice in fact, I think it's almost exactly the same. They just named it student instead of person. But I want to double back to this idea of private versus public things. Talk about that in a little bit more detail. I'm actually going to create a new file real quick just to do some testing. So we have this perfectly good student class. I wish to create an instance of the student class, so I'll make a variable. There's that new keyword. And in order to properly create a student, I need to specify some information. I need to specify the name, the email address, and the ID. Okay, I can do all those things. Here's my name, email address, and ID. Doesn't really matter. Probably wants me to import this guy. Wait, why are you mad at me right now? Oh, I forgot a comma. That's why you're mad at me right now. Boop. There we go. This is going to create a new instance of the student. And so now the question is, let's assume that, some stuff happens, and then later on I'm like, oh, what was the name of that student again? I wanna access the name of that student, right? I need to do something with it, print it out on a report or something like that. So how do I get the name back out of this object S? I have this student instance S. I know the name's in there. How do I get it out? I want to see that information. Well, we've been talking about the dot today. So one thing that you might want to try is something like this. Say s.name, and if we take a look at, where did that class go? Here it is. Yeah, s.name. So I'm trying to access this instance variable, right? Using the same dot notation. And if I try to do this, Eclipse gets unhappy and it says, the field student.name is not visible. And that has to do with the fact that we've declared it as private. So you might be saying to yourself, okay, if it's not visible because it's marked private, then maybe we could just mark it as public. And actually, that is a thing that you can do. You can mark your instance variables as public. And you'll notice that if I come back over here, and fix this line of code real quick, that, why are you mad at me now? Did I forget to save the changes or what? I forgot to save. There we go. After I save the changes that I make, you can see that it's not angry at me anymore. In fact, I can run this code and I can see that it successfully retrieves the name from that student object and prints it out. However, this is bad. This is not the way I want you to do things, ever, ever. Not in this class, hopefully not in any class, although I know that not everybody is going to be as strict on what I'm about to say as I am. The reason being that by making things public, it also gives me the ability to do something like this. Right? So that doesn't just give me the ability to see what the name is, but it also gives me the ability to change what the name is. To change it. That's really bad. That's really bad. For a lot of pieces of data, I don't want to provide that access, at least not very easily. Is it true that a student could change their name? Yeah, I'm sure that it happens, but it's pretty rare, and it's not something that I just want anybody to be able to change, right? I want to limit how people can change this information. I want to make it harder to make these kinds of changes, not easy. So, for every instance variable that we have, we really have two different things that we can do with it. I can examine it, I can look at it, I can read the value, or I can change it. I can modify it, I can write, I can modify that value. By marking things as public, it gives me the ability to both read and write to an instance variable. And my argument is that's too much access. That is too much access. What if I just want to read and I don't want to allow writing? How can I do that? Well, the way to do that in the way that I'm going to insist that you manage your instance variables. Again, I've already said this, but I'll say it again. Every single instance variable should be marked private. All of them. All of them, all of them. So then, okay, how do I do this then? How do I fix this problem? Well, we're going to provide methods to do this for us. And these are pretty standard methods, pretty typical methods that are used all the time, so often that we have names for them. Generally they're called accessors, but more specifically, accessors come in two different flavors. You'll hear them referred to as getters and setters, where getters are responsible for allowing somebody to read, examine a piece of data, and setters are responsible for allowing someone to set a piece of data. So if we apply that to our current situation, I want to be able to read that value, but I don't want to allow people to change the name, so I need a getter. I don't need a setter. Right? I need a way to read the value. I don't want to provide access to change it. So I'll make a public method called getName, and it's a very simple method. It's just going to return name. That's it. That's all that it's going to do. Why are you unhappy with me? Oh, I see what I did wrong. The return type was wrong. I'm sorry about that. Name is not void. Name is a string. So this should have a return type of string. My fault. And now that I've fixed that, over here, if I want to just simply read, I can say get name. So you'll notice that this is okay now, but trying to change the name, that's still no good because it's marked private. Marking things as private gives us more control over how the instance variables are accessed. In an ideal world, especially if you're worried about security, then everything would be marked private, and I would never use getters and setters. But in the actual world, we have a need to pass information around. So in practice, we mark everything as private, and then if we have a demonstrated need, then I can provide a getter. And if I have a demonstrated need, you can provide a setter as well. It would take a very similar format. So this is a getter. This is simply going to tell me what the value is, what the name value is for this current student. This is a setter. This accepts a parameter and will actually change the name of the student if that's what I want to happen, right? Again, I don't just put these in automatically. I wait until I've demonstrated a need, and then if I need to, I'll put them in. These are so common, in fact, that while you saw me write these out by hand, and I actually would encourage you to at least write a few out by hand until you get used to the idea, I normally don't write these myself. Getters and setters are so common and so simple that we actually will oftentimes use the computer to help us out. And so the way that you can do that in Eclipse, and I actually don't have a problem with you doing this on a homework assignment if that's what you decide to do, we're going to take a look at the source menu. Oops. Down here, there's an option that says generate getters and setters. If I click on that, it's going to show me a list of my instance variables. It's not showing me the name because I've already given a getter and setter for the name, so it's picked up on that. It said, oh, you don't need one for the name. But email and ID, I don't have anything yet, so it's up to me which ones I want to pick, and I can just check the boxes. So if I only want a getter, I just check the getter box. If I want them both, I check both boxes. And once I've decided which getters and setters I need, I can click the generate button, and you'll see that Eclipse will happily just spit that code out for me. I didn't need to write that. And that's okay, I like that. That's a good thing. That's thumbs up. But again, it's your job as the programmer to justify whether these are actually necessary or not. That's your job as a programmer. Ideally, we want as few of these as possible, as few of these as are required to get the job done. That's our goal. So always mark instance variables private, always, 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 always. If we need to access those instance variables, then we're going to mark them, we're going to provide getters and setters. One final thing on the topic, you'll notice that marking things as private only applies when I'm in a different file. So just because these are marked private, you'll notice that within this same file, it doesn't stop me from accessing those values, right? So values that are marked private, I can change them all I want within their home location, in the place where they are declared. This public versus private, these access modifier, only applies once I leave this file. So I can see public things from outside of this, but I can't see things that are marked private outside of this file unless I provide the appropriate accessors to do so. Everybody with me? I hope. Any questions? Yes?
I'm just curious if you just quickly scroll back to the test.
Oh yeah, sure.
Okay, thank you.
Yeah, no problem. Yeah, I right-clicked somewhere in the code and I went to source, which is here. We're actually going to be using this menu more as well in the coming weeks. This won't be the last time you see it, but it's right down here, generate getters and setters. Any other questions before we move on? All right. I've got, I think, 2 more topics on my agenda for you today. One is our good friend static. So there's our good friend static again, and you'll notice that here we actually have a static method. I want to be absolutely clear with you right now that I meant what I said earlier. I don't expect you to write many static methods from here on out. This is entirely new. This is actually a static variable, not a static method. And I'm going to go on record right now as saying that I'm not going to ask you to write any code that uses static variables in this class. But what I do want, again, to take a moment to reiterate, especially now that we have had more conversations about objects, anything that is marked static, that includes variables, anything that is marked static does not require an instance of an object, does not require the use of a constructor. It can be used on its own. Anything that is not static, so everything that's down here, does require an instance of an object, does require the constructor to be called. Another way of thinking about this is that static things are shared across all instances of a class. So that means that this person counter variable that is marked static, any instance of the person class can see this value, and it will look the same to all of them. They all share it. So if one instance modifies this value, all other instances will see that change. It's shared. There isn't one copy of this per instance. There is one copy of this that is shared across all instances, right? So this can be useful in some cases when you're dealing with a lot of constants. I'm bringing it up mostly for completionist sake. I want to reiterate again that for the purposes of this class, the most important thing that I want you to know is that non-static things require instances of objects and static things do not. If you understand that concept, then that is good enough for this class. There's certainly more that we could do, more that we could talk about, but that's the most important thing that I care about. And then the last thing that I want to talk to you about, but also very, very, very important, is a keyword that you may have seen pop up every now and then, but is useful in many different situations, called this. So if I type the word this in, you'll see it turns that dark red color just like some of these other words. It has a special meaning. It's a keyword. In fact, I'm fixing some things that have been bugging me this entire time. This is a way to refer to the instance of the object that this method is currently operating upon, right? It's often used to access instance variables like I'm doing here, and it may be required. Let me show you a case where it would be required to use this. Before, this line looked kind of like this, right? But let's say that I actually had the name of the parameter like this. This is actually allowed, but you'll see that it looks a little bit weird here, right? And Eclipse is even telling me that I'm assigning the variable to itself. Well, I haven't been specific enough. What I'm trying to do is take the value of this parameter and assign it to the instance variable that's called name, right? But I haven't this is ambiguous. It thinks that when I say name here, I'm still talking about this one, when I really mean this one. So using the this keyword removes all doubt. When I say this, I am referring to the instance of the object that is currently being operated upon, and so that means that this is an instance variable of that object. I would go so far as to say that anytime I refer to an instance variable, I personally, even though it is not required, prefer to put this dot out in front of it, you'll notice that it still worked before. The text is blue. That's a good sign, right? That it's matching up to the instance variables. So I don't have to include that. It's not required. It's not required. It's smart enough to figure it out without it, but this just removes all ambiguity. I look at this and I know right away that's an instance variable. Also, I mean, while perhaps not as common, consider colorblind people who aren't going to see that blue. Or maybe I'm not even in Eclipse. Maybe I'm, looking at this in, Notepad or something that's not showing me the colors, right? If that syntax highlighting is not available, then having this dot out in front is a very, very, very clear indication that I'm talking about an instance variable, not just a regular old parameter or a regular old local variable. We can also use, I think it's also important to understand, right? This matches up with the object that the instance of the object that I'm using when I call a method. So when I call this print method, it's going to send me here. What does this refer to? This refers to P1, whatever is on the left-hand side of the dot. When I call this print down here, again, it's running the same code. So what does this refer to? It refers to whatever's on the left-hand side of the dot, which would be P2. And I can prove that to you. In fact, I'd like to run this through the debugger again to prove to you that that is in fact the case, because I think it's such an important concept to understand. Here we go. Here I am on line number 30. I'm not worried about the constructor this time. I'm worried more about the print method. And so here, when you see, all right, here's P1 that got created, email, name, phone number. I step into the print method. I see a variable. It's called this. What is this? Well, if I look, I see the same email, name, and phone number. So this is P1, right? Whatever is on the left-hand side of the dot, that becomes this, and then I just run the code. Okay. So it does that, and then I move down to p2.print. It's running the same code, but what is this? This is whatever instance was on the left-hand side of the dot when I called the method. So you'll see that now these match the values from P2. So quite literally, when I call a method on an object like this, there is sort of an implied, this dot equals P2 that's happening, right? Before it runs the print method. And up here, it would be the same. It would be a similar idea. This equals P1, and then it runs the print method. This can also be used for methods as well. So if I wanted to call a method, I could say this.print right here, and that will actually call the print method upon this object. I think this is kind of a strange thing to do. This is a strange location to do it, but it's not a weird thing to do. It's just a weird place to do it in. So yes, I'm trying to think of what else I need to cover. Does anybody have any questions about anything that I've discussed up until this point? Okay. So then I guess the last thing that I'll leave you with is just sort of a little sneak preview of the assignment this week. I like doing that this week because this is a bit of a different assignment than what we've been asking you. This is a big shift, right? Everything we've asked you to do for the first 6 weeks kind of falls in the same category. And we're now telling you today, like, hey, take all that stuff and organize it in a different way. So this is a big shift. Assignment 7 is going to feel a bit different than some of the past assignments. We're asking you to create classes to represent students and courses. So we give you the instructions on what methods to include and how these methods should work. We even give you a good first step on what these instance variables should be. And if you've been paying attention, right, these should be as simple as saying private, whatever type you want, whatever name you want to knock those out. The thing that I want you to be aware of is you're not going to see any static methods in here. No more static methods. Has big implications. And then when it comes to the course class, when you get down here to the course class, this one right here trips people up. Where did it go? Just had it. Here we go. This one right here trips people up. A roster of enrolled students. So if I'm thinking of a course has a name, right? Course has a number of credits. So the name of this course is CSE131. Number of credits is 3. A course also has a roster of students who are enrolled in the course. What should the type of a roster of students be? Think very carefully. So it's more than one student. I'm going to tell you right now, it's not going to be an array of strings. This is by far the most common incorrect approach that I see. This will work to keep a list of names, right? List of names of students that are in the class. But there's more to a student than just their name, and if you don't believe me, you can take a look at the student class, right? If I scroll up to what we were asking you to track for the student class, I've got their name, their ID number, their credits, bare bucks balance, all that fun stuff. So what we actually are trying to represent here, I don't want just a list of the names of the students. I want the actual students. So that's going to be a more robust, a more useful way of tracking information. Think about it. If all I have is strings, then as I'm going through the course, all I can see is a list of names. But if I have an array of student objects, then I can access anything that is contained within those instances. So yes, I can access the name, but I can also access the ID number, and I can access their GPA and all that other stuff that the student class is going to provide to you. So when working on the course class, especially the roster, we want our roster to be filled with fully formed, fully functional student objects. Don't fall into the trap of just recording one piece of information about the students in the class. That's not useful enough for us. If I ask you what's the average GPA of everybody in the class, you won't be able to tell me, because that's just names. That's just names. I can't get GPA out of that. Okay? The same thing's going to be true for parameters. Don't be surprised to find parameters of methods that take in student objects. That's the whole point. That's the advantage of having objects do this stuff for us, is we now have these nice, concise, encapsulated units that I can pass around instead of having to track all those values individually. Before today, if I tried to ask you to do something like this, we'd probably attempt a parallel arrays approach, right? Where they had like one array for names, one array for credits, one array for ID numbers, or whatever the case. And it just gets too clunky. It just gets way too clunky too fast. So object-oriented programming goes a great way towards helping us organize our code, keep it easy to read and easy to understand. Okay. I'm done. I finished everything that I wanted to chat with you about today. So I'll hang back for the remaining few minutes in case anybody has any questions. But otherwise, I will plan to see you all in labs later on this week. Thanks, everybody.